Hello, everybody. Yes, my name is Edvīns. At the moment, I'm a doctoral student at Latvia University of Life Science and Technologies. I'm studying civil engineering or structural engineering, and I have dedicated my work to the fire protection, mainly of the timber structures. But since I have gone quite deeply inside the fire protection, it has become clear that the timber is not the only issue there, and there is lots other things beside the timber. So meanwhile the studies, I also do some job. Approximately 10 years I have worked in the field of manufacturing of the timber building kits, and after that I have worked as a within the certification body, which was the international certification body. It's BM Prada, and I did some European technical assessments, which is a specific way how to CE mark products which are not typically harmonized with European harmonized standards. So 6 successful assessments are in my count. So I think, yes, that's quite a lot, and gave me a lot of experience with standardization system and all kinds of standards we have so far. Okay. During this studying process, I have raised one interesting question: multi-story timber buildings in Latvia, why not? And with all possible meanings of this question, why not? Why we shouldn't use timber buildings, or why are we not using timber in our buildings? So this is the main question I have raised, and so far I have found many arguments. One say that the Latvian regulation is incorrect; it makes problems. Others say that the fire service department is restricting that and making obstacles for this. Others say that the simple experience of the engineers doesn't allow us to use timber in our buildings, and so on and so on. So to understand that, I have to start looking inside the regulations. And first of all, I have to say that for everyone who is not familiar with the Latvian fire regulation, that this is a set of prescriptive rules. These are not performance-based. They are made with 2 main lines. One comes from the construction law. This is fire safety of the structures, and all the supplementary structural regulations which define the fire safety of the systems implemented inside the building, such as water supply, electricity, and so on. And there is the second line, which comes parallel to this fire safety of structures, is the fire safety regulation, which comes from the firefighting rules. And this gives the regulation for the building during its time of use. And all this is supported by the Latvian standards. So by name of Latvian standards, I mean all standards that are adopted or created and are current for the Latvian Republic of Latvia. These are Eurocodes, harmonized standards, all test methods, and so on. A lot of standards. So that is quite a difficult regulation. In order to understand it, first of all, what we have to look at is that we are dividing all the buildings in the use categories or use types. At the moment, we have 9 of them. These categories are, this categorization is similar that we have seen in regulation from other countries, but there are some differences in this. How does it work? So first of all, for all the building use types, we have 3 protection levels. This is the highest protection level is so-called U1, and it is subdivided in 2 groups, A and B, which means the A is for the buildings which go high, so this high-rise buildings, and the B class is for the wide buildings like the storage areas, shopping malls, and so on. For the U3, the lowest protection level category, there is no such a subdivision. Then, parallel to this protection level, we have the prescribed fire load density groups, which doesn't mean the same thing as it is for the building use type, because there are building types where the different building within the same use type has different load density group. And there is also some algorithms to calculate the fire load density in the general way, which contradicts with the Eurocode system, but that's a different story. And then we have the prescribed performance limits, which serves as a filter for all of these performance classes and protection levels. To understand how it works and how it is aligning with the timber buildings, I have prepared one short example. For example, imagine if you want to create a 5-story residential building, and you have initially thought that it should be made of timber. So what do we know? From the prescriptive rules, we have 3 levels of the fire protection design and fire protection level, and we normally would like to have the highest protection level because we want to save the people or the property inside the building. Our rule says that dwellings have fire load density which is below 300 megajoules per square meter, which contradicts with the informative Annex C from the Eurocode 1. This is interesting because it also contradicts with the Swedish fire load handbook and other informative materials that are around in the world. That is something that I suppose we will have to change in the future. And then we come to the performance filters. First of all, we have defined the maximum allowed size of fire compartment. Fire compartment, the definition in Latvian regulation, it differs slightly from the definition in the Eurocode, as you can, and therefore we have different attitude for this parameter. Let's see. For example, if we want to build a highest protection level building, so it will allow us the compartment size for 5,000 square meters, which is not exactly as it should be because the larger the area, the higher the risk of the fire occurrence. And this means that it is not like a restriction, but the opposite. When we are talking about the fire resistant walls, it is allowed the minimum fire resistance class for the load bearing structures is 120 minutes. And then comes the tricky part. It's the regulation says that from the point of view of combustibility, the structural elements should be A1, which means that in the highest protection level, use of timber is completely restricted. Distance to the egress exits is 30 meters. So it means the highest protection level, we won't achieve it with the simple means. Then comes the medium protection level. And as you can see, the allowed size of the fire compartment is twice smaller. So it is a little bit safer situation from the point of view of fire protection. But anyway, the combustibility limit, it creates an impossible barrier for the timber as such. So it means if we want to build a 5-story residential building, we have to go for the lowest protection level. And there we can see that there are no limits for the combustibility. However, it says that it is not allowed to build a building which effective floor height is above 8 meters. So it means no 5-story building. It is maximum we can reach the 3 stories made of timber. But there is an exception which says that we can actually build a 5-story building or more if we reach the resistance time of the structural elements, the lowest level 60 minutes. Combustibility of the structural elements are as untreated timber, DS2, D0, but it's covered with the protective cladding, which has the combustibility limit as it is for the medium protection level, but with additional requirement for the fire protection class. for the 60 minutes. So from this, I already can see that there are so many additional restrictions and things that shows that someone is very afraid of the timber buildings from the point of view of the regulation. And if we compare these requirements, it seems that the lowest protection level for the timber buildings is larger than the medium fire protection level in a conventional way. So this is, I think, already obvious reason why designers and architects don't want to handle timber. It makes a lot of additional design process for the whole design process. So then I raised the question why we are so afraid of the timber buildings, and I got inspired from the research done for the Switzerland, where the authors searched the answers inside the statistics created by assurance companies. For Latvia, I can't find such a data because we do not have a mandatory property insurance as it is in Switzerland, but we have the statistics gathered by the National Fire Service. What we can see from these statistics that logically the most fires happens in the populated places like cities. In 2019, there was 2,200 building fires, where 84% of all these fires were residential fires. So it means that the residential buildings were on fire. In 2019, the death rate was 4.5 persons on 100,000 inhabitants, which is one of the, basically it is the worst ratio in Europe, and it is one of the worst in the world. So the death rate is too high, I would say. And when we look at the causes, what caused those fires, then for the residential buildings, in 32% cases, that was unattended cooking device. So it means we are careless when we are cooking something. There was 20% fires caused by careless smoking, and 70% fires caused by irresponsible use of fire. So it looks like that people are making those fires quite often, and this is quite a problem. Then, what are the typical traditional Latvian buildings? This is one of the buildings I have on my road home. Every day I see this building, and beside this building, some years ago there were 3 other similar buildings which have been burned down. As you can see, these are old buildings built between world wars, and they are poorly maintained. So this is another reason why I think we are so afraid of the timber buildings. So the first challenge for the fire protection and the architecture of the timber buildings is those stereotypes, which are based on good foundation. Other picture I have found is also on the same road home. It is a newly made timber building, but what can we see here? What is that? So it is some kind of additional chimney made of a single skin and attached directly to the timber cladding facade. So it is the solution, self-made solution, which is time bomb actually for this nice looking building, which is built in the way how we have often seen in Nordic countries. So then you can imagine that when we look at this Norwegian high-rise building made of timber, Latvian National Fire Service will look at it as a 20 times multiplied our national timber building, and that is causing the problem because we do not understand how to make our buildings safer. And for this, the education and knowledge is key factor for this. And what Andrea already showed, that there must be understanding of the fire dynamics, heat release rates, and all how fire works. This one is the parametric fire scheme, which is then compared with the structural response to the fire so that we can analyze whether the structure is good enough for the purpose or it's not. Then we analyze the evacuation process, where our tools how to theoretically make a model without additional testing. Of course, we can then calibrate these values with the actual tests, because they must be calibrated. They are influential by the mentality and other things. But what we want to have the safety margin in the structure. And also we want to check whether what is the response of our fire service. We want that they also are in safety during the event of fire. When we have this knowledge, and everybody inside the industry will have this knowledge, basic knowledge about the fire events in timber buildings and all other buildings, I think then we will lose some borders what we are having now, some restriction for the timber. How to do that? One thing that I have found, that there is no problem with the firefighting service, because we know who is doing the firefighting and they have a option how to get education. We have fire safety specialists which also have ability to get education and knowledge. But there is an interesting thing with the fire protection, because at the moment fire protection is handled by architects and structural engineers who have admitted that they have insufficient knowledge about the fire engineering as such. So that is the main question: who has to be responsible for fire protection during the process of the design of the building? And as I have seen from the other nations, there is always a so-called fire protection engineer, and there is such a profession and there is such an education for these engineers who work in the team with an architect, with the structural engineer, with the builder, and everyone gets clear picture what is going to be expected fire event inside the design building. So it means that we are lacking one large piece in chain who could provide the complete system for the design process of the buildings. When we will add this link to the chain, if we will have the timber buildings, I'm sure of that. So next challenge is to implement new knowledge in reality. And we got opportunity to make some testing or exercising with the support of Latvian wood construction cluster, National Fire Service, and Salaspils municipality, together with the architect Miķels Putrams, who already have demonstrated this building under construction process at the moment. It is the 7th preschool education facility, which is made completely of timber, and it was, from the Latvian regulation point of view, completely impossible to build or design such a building. But we created the theoretical fire event in this building using the knowledge or these principles I have shown before, with additional knowledge about the evacuation process, where great support was from the SFP handbooks, and there is a very nice collection of the scientific papers which are very relevant for the Latvian kindergartens, because the research done and represented in these handbooks is made in Russia. So Russia shares with us some part of history. We also have some actually kindergartens are made and built up very similar like it is nowadays in Russia. So they have the same seasonal issues. They have winter. Basically, that is very good data for us how to make a theoretical model of fire events and egress scenarios for Latvians. So we used the data and created a very large and special occupant profile list. And for each of the occupants, we created a scenario trees where we made for them action plans, which should be afterwards implemented in the fire safety plan of the building. And then we placed all these data inside the computer models and made an actual computer simulation of all the processes happening inside the building, and it amended the initial design greatly from for the architect. It showed a lot of interesting things, how things might happen during the fire event, and it also helped the firefighting services to see that we are not trying to implement timber just because we want timber, but we also are thinking about the safety. Okay, in this case, the safety was a little bit over designed, but anyway, this is one way how we could represent the principles, the knowledge, the competency from other countries in the world, and then make a good solution for our own timber building. So to summarize all this, I have created some sort of scheme where I have placed on the top the education, which is a core necessity to have timber buildings in Latvia. Then we have to think about the profession. There is many options. One option is we educate our existing professionals in the field so that they could also handle the timber buildings in the more professional way. And we need new engineers in the field of fire protection. Then we need and must have very good cooperation among ourselves and with other living inside Europe to have mentioned harmonization between national regulation and European regulation, so that all the knowledge background and scientific background ties up in the same information sphere. Absolute necessity is quality management and code of ethics for these engineers to have some kind of reliability from the customers, and only then we can talk about regulations, how to change the regulation. First comes the knowledge. So at the end, I would like to say that there is nothing wrong that we have so many challenges and problems, because as we know, we have came from very bright past, and we are in the process of the development, and this is just a normal process, and I think we will all reach the bright green future with the timber buildings, and that is achievable for us. Thank you very much.